All right, so picking up where we left off. Oh, there we are. So we had, I need to write that value in there again then, I guess. 0.8165 469, or 47, I guess, for 6 decimals, 47. And we're going to do the next two. Now, the only thing that's going to change, of course, is the distance in the y values, right? We already talked about the distance and the x values remaining constant. So in our calculator over here, we already have one of the two y values, the 1.322876, right? And since it doesn't matter the order that we subtract them in, I'm not going to change that one. So I'm going to do second enter to bring up the previous line, and the thing I'm going to change is the 1 point with the 6 zeros. And the 6 zeros are going to become 581139. And I'm going to hit enter. And now, again, the distance between these 2 points is 793,221. We're going to do this 2 more times, okay? Again, the distance in the x values doesn't change. So I'm going to do second enter to bring up the previous line. But I don't need to change both of the y values. One of the y values is going to be the same, right? The one that's 1.58 and so on. So all I'm going to do is to change the 1.31. And that's going to become 1.802776. And hit enter. So this is 0.782063. And then we'll do the last one, change one more time. This time I'm changing the 1.58 number to the number what? Just 2. And you can either delete at this point or you can go back through and turn them all into zeros and that will be fine. And then this one is 0.775498. What do you notice about these distances? They're very close together, that's true, and they're getting smaller, right? Slightly smaller each time. Now think about the graph. I know this wasn't sort of like an accurate graph at the bottom of my screen, but it is the idea. It should make sense that these distances are getting smaller because it's steeper at the beginning part of the curve than it is as the curve continues. It does sort of have this sort of a flattening out feature going on, so that kind of makes sense. Now, but go back to the directions. The directions said we're going to estimate the length of the curve. We have found 4 distances. What do you think we need to do with those 4 distances? Add them together. You got it. So in our regular screen here, we're going to be able to add these values together. 0.816547 plus 0.793221 plus 0.782063 plus 0.775498. And here's where my statement about how many decimals we're going to use changes. We've kept 6 decimal places so that we keep things as accurate as we need for our answer to have 4 decimal places. So our final answer is only going to have 4 decimal places, but we kept it to 6 decimal places all the way along so that our final answer is not off in the 4th decimal place. Okay? So jot that note down to yourself if you need to remind yourself how many decimal places your answer needs to have. It's only 4. So our distance, and this is an approximate, is 3.1673. All right, we're going to repeat this process. We're going to fly through it really fast for 8 line segments. Now, all of the darker gray boxes, we already know those x values. We already did them. And we know those y values because we already did them. We had a 0, we had a 0.75, we had a 1.5, 2.25, and 3. And we had the corresponding y values from before as well. So this was 1, 1.322876, and then 1.581139. 1.802776 and 3. I'm sorry, it was 2, wasn't it? 2. Sorry. And then we're going to go back and we're going to fill in the blanks. So we need to know what is halfway between 0 and 0.75. Do you know? 0.375, right? And then what's halfway between 0.75 and 1.5? Well, you might not be able to do that one in your head quite as quickly, but you can add the two together, and then what would you do? Yeah, so you'd add, sorry, I wrote the wrong number down, didn't I? 0.75 and 1.5. So you add the two numbers together, and then you would divide by 2. So this is 1.125. You can do the same thing with the 1.5 and the 2.25. Add them together, divide by 2. 1.875. And what's the last one? 2.625. 2.625. Okay, so those are the x values that we're missing. And we can use the table in our calculator to find the y values that correspond to those. So I'm only going to put the y values that I need to find, or the x values I need to find the y values for, into my calculator at the moment. So I have 0.375, 1.125, 1.875, and 2.625. These are the outputs I need to care about at the moment. All right. So I have 1.172604, 1.45, 7738, 1.69, 5582, and 1.903943. We're going to go back to that distance formula that we did before. So let's go through again, make sure everybody's on the same page on how that works. We're doing a square root. We're going to open the parenthesis and extra parenthesis. What's the difference between our x values on this particular problem now? The 0.375, right? It's not going to be 0.75 like before. We've split that in half. So all of them are going to be 0.375, which I'm going to square, like that. Then I've got plus, and I'm going to do the pairs of y values again, just like I did before. So I'm going to do 1.72604 minus 1 point, and I'm going to put 6 zeros in there. Square it and close my parenthesis. Oh, I left off a my value's wrong. I'm sorry, I've got a 1 missing. 1.17. Yeah. That looks better. So it should look like roughly half of the values of the numbers I was doing before. I'm going to just write them in the boxes themselves instead of between boxes and leave off my last box, just to try to keep things a little bit neater on my screen. So I have 0.4128, 16. I'm going to change my input for the value of 1.00 to the 1.322.876. Got 0.40, 3988. Yeah. I'll go back in and I'll change the 1.17 value to 1.45. 377, sorry. 7738. I've got 0.39, 8513. Do it again. We'll change the 1.3 value to the 1.581139. All the values are decreasing again, right? Just like last time. 0.394782. Change my 1.45 number to 1.695582. 0.392074. We're getting close, guys. We're almost there. All right, we're changing that 1.58 to 1.8027. 776, 0.3900, and 199 would actually turn into 20 if I've got 6 decimal places. If you put 19, it's not going to affect the final answer of your value either, but just to be clear. I need the 1.69 to change to 1.903943. 0.388407. Last one, we're going to change the 1.9 number to 2. And I'm just taking out my zeros. You can turn them all into zeros if you'd like. Did I screw something up? Oh, I took out the wrong one, didn't I? That was not so good. Let's try that again. Should have taken out the 1.8 number. Okay, that looks better. 0.387107. And the last thing I need to do is then what? Add them all together. All right, so this time I have 8 values that I'm going to add together. It's quite a few. But the answer is going to be close to the 3.16 whatever I had on the previous screen. Okay, it's going to be close to that. So 0.412816 plus 0.403988 plus 0.398513 plus 0.394782 plus 0.392074 plus 0.390020 plus 0.388407 plus 0.387107. And I end up with a distance value approximation on this one. How many decimals am I going to use for my answer? 4. Very good. So this would be 3 point what? 1777. It is very close to the previous value, right? That's awfully close. In money terms, that's a penny different, right? And think about that, right? The second decimal is the only one that mattered, the only difference. Any questions on this process? All right.